Well, hello there, and welcome back to another episode of Means Development. Today we're gonna do a few more tweaks and improvements to the mother vehicle before we... Well, actually, we're probably gonna be working on the mother vehicle for some time still, but yes, today a few more tweaks to the actual... shall we say, core vehicle itself before we start looking at cranes and other funny things like that. So what I've done since last time is I fixed a bunch of small problems like that assert that kept failing all the time. As you can see, I've also added 2 new wheels to the vehicle. And so this is now an 8-wheel vehicle, and I think we're gonna take that and run with it today and do some fun things with that. Before we do that, though, there are a few small things that I'd like to change. Some values that I actually haven't been able to really properly tweak previously because I haven't had a need for them, because I haven't created anything this ridiculously big in previous games. So the first thing that we're going to change is, you can't see my keyboard now, but I'm actually like turning full speed. I was trying to make a very sharp turn to the left, and there's a system in the vehicle layer and the physics. Oh damn, I'm gonna fall down. Let's just destroy this one and create a new one for us. So hello, another mother, please. So we can turn this much, but the amount that can be turned actually goes down with the speed of the vehicle. Now if we run into this thing here and we do like a full turn like this, you actually saw that when we hit, or you might have seen it, that when we hit the block it actually just turned a lot more. And that's because the speed went down to 0 and you were able to do like a full turn. So basically what I'm trying to say here is that the faster the vehicle goes, the less you can actually turn the wheels. Like now I have a full turn to the left again, and the wheels are almost not turning at all. And this is really handy for fast vehicles, but not slow ones. For the mother, I'd like the turning to be sort of the turning amount to be constant. Another thing that I'd like to change is that since these wheels are so huge, they're actually probably a little too huge for this vehicle. We might make them a bit smaller in this vehicle, in this video, I think. But anyway, the turning is really rapid, as you can see, and we should change that as well. So let's do that. Let's see, where's my vehicle definition? Where is my vehicle definition? Right, so here we go, mother vehicle.json. And yeah, I've added a few more things to this. So if you go to vehicle description and we go have a look at here, this new section here. So we have something called steer rise rate, steer fall rate. And we can just put these guys in here. Let's make them 0.5, I think, or something like that. Like something really slow. But we can do like fall rate just as a demonstration, make that a lot higher. So now you can see that when we turn, the wheels turn very slowly. But since I have the fall rate much higher, the return when I let go of the button is going to be really fast, like that. And so I think this is probably this sort of rate of turning the wheels is probably much more realistic for something this big. So let's make this the same low value, and now the return is equally slow. And this means that when you're driving around with this mother vehicle, you have to sort of plan in advance a little bit how you're going to turn, because it doesn't return the wheels to the straight position immediately, which I think is actually kind of interesting. Let's not make it super slow, but I think this is probably pretty good. So the other thing then, if we can get this guy to stop, the other thing is steer versus forward speed, and this is an array. So what we'll want to do here is create an array of value pairs. So the first one is speed, and the second one is how much to turn. So this is a value pair right here. And we'll just put the we'll just make it essentially override the basic or the defaults. So if you don't have it, it sets these things, and these are the ones that I had previously. So at 0.0 meters per second, the steering at 0.75. That's actually kind of interesting, because we never actually apply the full steering. I don't know why I had it like that, but let's enable the full steering here for the mother vehicle. At 5 meters per second, it's the same. At 30 meters per second, it's already a lot less. So what we can do here is we set this to something really high, like 1,000, which we will never reach, but that's sort of the idea. So at 0, it'll be full turning, and at 1,000 meters per second, it's also going to be full turning. So it's essentially always full turning. That's what this means. So now we should be able to stay on our little level a lot easier, because no matter how far we're going, we're still going to be able to turn as much as we can when we're standing still. And now we can see that the vehicle just controls, in my opinion, much nicer and much sort of, it feels much heavier when you can't just, you can make really tight turns, but it takes a while to actually get the wheels to rotate that much. Yeah, this is much better. Okay, so that's one thing. That's kind of my first point of today's to-do list done. And I'm gonna cross it off. Then I was thinking we would make the wheels a bit smaller. So where's my Blender shortcut? There it is. And we'll go into Mother, and we'll go into we'll take the chassis away for a bit, and we'll do, what do we do? Wheel block out. I wonder why we can't actually see it. Oh, it's because it's hidden. Right, so let's move that to the origin, and we'll just scale this down by, let's say, 0.8. Start with that. So that would mean that the dimensions are 4.8 and 4.8. Yeah, that's the diameter. And height is then that. But I think actually we'll probably want to not include this guy. Yeah, well, we'll see. We'll see how to set this up. Anyway, let's export this as an FBX, And we'll put it in mother wheel, and we'll set the proper presets. And we could probably have just left the game running. And that would have worked just fine. However, now we can see that, okay, the visuals don't match the physics anymore, which is obviously something we should have expected. And the wheels still might be a little big, but I think we're kind of approaching sensible sizes now. I mean, they're intersecting with the body when you turn them. That's not really a problem. We can change the shape of the body, make room for the wheels. But yeah, maybe we'll keep them like this. We can make them even smaller later if we need to. So now we need to go into, first of all, the blueprint of the vehicle. Vehicle blueprints, and mother. And we need to, so what was the diameter now? The diameter is 4.8, so that means that the radius is 2.4. So radius 2.4 for all of the wheels. So 1, 2, 3, 4, 5, 6, 7, and 8. And then we have the convex hulls that we did last time. Cool. And how did we scale? I think it was 0.8 times 2, so that would mean 1.6 is the height. In other words, the width. Since the cylinders are sort of specified on the side, then they're specified standing up actually, but the wheels are lying on the side, so that's why it's called height here. Okay, so that's the blueprint, and now we just go into the into this definition, and we set this to 2.4 and 1.6, and now we should have the physics matching the visuals. This time we actually needed to shut down the game because blueprints aren't actually hot loaded, as I mentioned earlier. And this looks pretty good. We have a truck in the way. This looks pretty good. Yeah. I mean, they're still just absolutely enormous. Let's try one thing. Did I have let's see here. Where's the development common? Do I have like a scale mannequin object here? Object blueprints, scale mannequin, development/scale mannequin. Let's copy the name, and we can go into, now we need to go into the actual game code, which is obviously Zig. We do means app, and in means app we can add a debug spawnable object. So basis debug overlay, add debug spawnable object type, and this would be the scale mannequin. And distance from surface I think is just 0, and no F. And we can build this. So now we should be able to just place essentially like a person in the scale of the world next to, well, anything really. To kind of verify that, okay, this is this big or this is that big. Let's just go with free camera next to this guy, and we should be able to do this, and we can go scale mannequin, and boom, and there's your average person in the scale of this world. So the wheels are still absolutely enormous, but that's sort of that is the idea. They are less enormous than they were. And right, so now that we have this, we're probably going to group these wheels together a little bit more, because I had an idea for, like I mentioned previously, that I might want to make this vehicle tracked, and I can't do tracked vehicles currently, physics-wise. But if we have this, I just took a screenshot of the game. If we have these wheels sort of grouped together a little bit more, we can sort of get at least slightly the way to the tracked vehicle look by essentially putting like a cover on top. Let's make this a little larger. I'm drawing with the mouse here, so bear with me. Put like a cover on top of two wheels, like a wheel pair, something like this. It covers sort of like part of the wheels, and this would move sort of along with the suspension of the wheels. Then we would have another one like here, and I think this should already sort of half achieve the look I was going for with like a tracked vehicle, and then we can see about perhaps making it truly tracked later on. But for this to look nice, I think we need to group the wheels a little differently. So let's keep the game running, and we're gonna just take this guy. I'm gonna move it off to the side so that we can see, and let's start moving wheels slightly. So let's move the front wheels just a tiny amount backwards. And maybe we need to actually... the visuals probably don't update. No, you can see that it has actually moved. Alright, let's just keep... I need to actually move the vehicle around for those to actually snap into place. Let's just... let's just do this a little while to see how we move. So I moved these, the rear wheels a little forward, and then we'll do the same thing for these. So these are going to be for the middle wheels, that is. So move them just a tiny amount closer to each other. So now if we have this guy, and we can probably drive it from this perspective. So how does this look? Looks kind of interesting, I guess. Looks kind of interesting, I guess. I think the rear wheels should perhaps just be ever so slightly moved forwards. So let's do that. Like so. And how is that? And again, we have the physics bodies not being interpolated, so it kind of jitters a little bit. Let's turn them off for now. And yeah, I think this looks kind of all right. Maybe they should be moved even closer together. Maybe they should be moved even closer together. What do you think? Let's try that. So front wheels a little closer together. All right, now they look that they're properly sort of grouped, if you will. And the rear wheels as well. There we go. Yeah, now they look like they're properly grouped. 2 and 2. I think this probably looks okay. All right. So I think we're gonna go with this for now. And actually, let's just before I say that, let's make sure we can actually drive over that bridge now, because We have moved the wheels and we've also made them smaller, so the sort of clearance is going to be reduced. Let's make sure we can actually still drive up and over that bridge before we move on to the visuals, the covers. All right, let's see what happens. Can we actually clear this bridge now? Let's go slow. Yes, we can. Okay. I mean, I'm not sure that this bridge is going to be sort of the best, or that this is not like a properly laid out and well-defined measurement of whether or not this vehicle has the required amount of clearance. I mean, it's the front is pretty close to the ground here when we are at about this place. Let's see, can I make it stop there? Yes, I can. So it's like a few centimeters from the ground when you're coming down the ramp like this, but it's not necessarily a problem. Let's assume it is enough. Okay, what's going on? Why can't I drive it now? Did I actually pause the game? I did pause the game. Why did I pause the game? I don't need to pause the game because I have handbrake. Okay, anyway, let's consider this sort of good enough for now, shall we? And move on to other things. Should the front wheels be just a tiny amount moved more forward? They're still further back than the rear wheels are from the rear of the car. Maybe they should just be moved a tiny amount forward. Let's try with that. Like so. I think maybe we're now a bit more safe. So that the front doesn't hit the ground that easily anymore. Or at least that would be the idea. Yeah, I think this looks better. This looks it looks properly huge now that the wheels are a little smaller, because it just looked like a sort of a vehicle out of scale previously when the wheels were just like ridiculously huge. They're still ridiculously huge, but they're sort of just like, it looks maybe a bit more realistic. Yeah, they're still they're still just absolutely huge. I can do things like this. This guy doesn't have any physics, so you can just place them anywhere. Yeah, the scale is pretty good, I think, right now. Those guys are just gonna stay in the air. Okay. Fun. All right. So, what about those covers then? Let's maybe start by just modeling a quick sort of wheel cover. I don't know what to call them. Are they like wheel hubs or what are they? But if we have the wheel there, and actually let's not do that. Let's duplicate this a little bit. Get it there, and then duplicate it again. Or we can actually take this and we can duplicate it internally. And then we move it into position. All right, so we have it maybe a bit lower still. It's actually just. I'm just gonna eyeball this for now because we haven't like really. Oh, what the hell? What? Where are my texts? That's interesting. Where are my texts? Did you see that? There was no texts. I've never seen that before. Yeah, we haven't really decided where the wheels are gonna be properly positioned on the vehicle, so I'm not gonna spend a lot of time on that. I'm just gonna eyeball it for now, and it looks to me like they would be positioned roughly there. And maybe just a tiny bit closer. Something like that. That's kind of the correct position, and then sidewise they are a little bit closer still. Something like that. We'll put in some nice looking suspension at some point, if it can actually be seen. I don't know if we can't really see it, then there's no point in putting in any kind of suspension at all, but let's assume it can be seen. So let's move the cursor to selected, and that is where we will put in a new cube. Just like with everything else, let's not spend a huge amount of time on this. Because it is still just block out, but just to get a sort of nicer idea of and explore some visual concepts, if you will. Okay, so what should this look like? I think we're gonna scale it. No, scale it up a little bit, like so, and then we're gonna move it up a bit like so, and then we're gonna take this guy and scale it in. Yeah, like so. Maybe we'll even do something like this, and we'll scale this. No, scale. Oh. Y. Y, not Z. Right. And then we'll scale that by Y as well. Something like that, right? Right. And what do we do then? Oh, we don't do that. Let's not do that. Let's instead do this. And let's do. Yeah, I haven't really thought about how I want this to look, and maybe this should be like ever so slightly larger because the wheels are gonna move up and down, and this thing is also gonna rotate, I think. But we're still not that much. So scale, not X, just ever so slightly larger. We have a lot of space there because they're so separated, the wheels currently. Right, let's do that, and then let's just keep it simple for now. So move this somewhere there, something like that further. Move that guy over there, and just cut out like or like bring a piece of this sort of out a little bit. Let extrude it is the term I'm looking for. We can take that away. We can take these guys and just extrude them out, right? Something like that, and then just take the face away. Let's not even bother with like an underside. Or should we? Should we bother with an underside? What we could do is perhaps we could put in a modifier. We can put in a solidify modifier, right? And this guy allows us to just put in like a border there, almost like even thickness, maybe only rim. Yeah, let's not do only rim. Back face, no. What? Here, this is what I'm looking for, face orientation. So if we do only rim, then the inside is going to be sort of see-through. That's perhaps not what we want. Let's do not only rim. Yeah. Okay, let's go with this. Let's see what we end up with. This, I mean, this might end up being kind of silly, but let's go with that. So we'll have 4 of those, and they will sort of rotate around this this guy, kind of like along with the suspension of the wheels. That's my plan. That would be my plan. Okay, and we can do, what do we call this? Do we call it? This one just called wheel cover block out. Is that called like a wheel hub or something? I don't know. I'll call it wheel block out for now, or wheel cover for now. Right. We need to move it into to the origin for exporting. So mother wheel cover. That'll be good. Export that. We can bring it back to there. Right. And I think it's supposed to be on the, like, exported as if it is on the left side. So what we want to do now is probably use the same sort of system as for rendering the actual wheels, right? So the wheels are rendered with a vehicle wheel renderer component. This is part of the VHL library, but we can maybe make a copy of this, which would be like mother wheel renderer component, something like that, which would be, we would place in means, and it would do the same thing. It would render the wheels, but it would also render the covers. So let's do that. Let's copy all of this. Create a new game object component here in means. New file, mother wheel renderer component, and we need to, of course, we need to add a zig extension to that, and we'll just copy this in. I don't know if we need VHL. Let's just keep it as it is for now. So this guy would be mother wheel renderer component, right? Okay. Vehicle controller component. Maybe we actually need it. Yeah. Okay. Never mind. So means that mother wheel renderer component. Okay, and we need to register this component so that it can actually be found by the app, and we can do that in, no, it's in here, it's components. So pub const mother wheel renderer component equals import that same file name dot mother wheel renderer component, and we'll put it in the list. And now we should be able to build, but we don't, and that would be because we actually just need to import VHL as VHL when we are in the means project. Let's make sure this works. Get an error. what is the error? Oh, the error is that we have the game running and it can't write to the DLL file. That would be the error. Okay, so let's have a look at what this thing actually contains. So when the object is created, it figures out the vehicle wheel controller component. I wonder what it uses that for. Might not actually need it for anything. It might have been something I was playing around with earlier. So actually what we can probably do is just get rid of that for now. We can get rid of essentially all of that for now, which means that we can also get rid of this guy. Yeah, because this thing doesn't really use that for anything, right? But what it does is it has this public function, create wheels, with wheel material paths and wheel mesh paths. So materials and meshes. And this guy is called from another component. Let's just move that up to the side. Actually, we can shut it down because we have it here. So means vehicle component. And means vehicle component actually looks for, yeah, it does here in object created. It looks for, so get game object, get component, vehicle, wheel renderer component, and puts it here. And what we can do now is then const mother wheel renderer component is means components mother wheel renderer component, right? Mother wheel renderer component. Yeah. Oh, we don't have means anywhere. I think that's probably just like you need to somehow be able to. Yeah, we need to probably do something like this. We need to do const means is import means.sig, and now we can access it, and we can have a mother wheel renderer component. In the future, we'll most likely put this into, like, the mother will have its own vehicle component rather than just using the generic means vehicle component. But let's put this here for now. So just like if we are on the client, we'll also figure out if we have one of these guys, and if we don't, then it's completely fine. We don't. Then this thing will just component, and it's of course called self. Let's just write a comment here that this may be null, and that's fine, because since these are optionals, they have this question mark here. When we use them, we need to check, right? Do we have one of those guys? If we do, then we can use them. So mother, and yeah, that's it. Then we create the wheels, and we need to do the same thing here as well. So a little bit of a hack job, but it doesn't matter. It's fine. Okay, so the way we can now test that we actually have this thing working is by making some small change to the rendering. So how do we do that? Let's all right. Let's if right side wheel, then we flip it. Let's just comment that out, and we can build. And it should succeed. And now if we go into the game, nothing should actually change. the mother should still have the wheels rotated correctly, because we haven't actually changed the blueprint. So here we have somewhere, if we can find it, vehicle wheel renderer component, right? So if we go here, we explore to that, and as we've previously seen, this is just a normal JSON file. Nothing weird about it. Vehicle blueprints. So we can just actually change this to a means.mother wheel renderer component, which of course is the name that we specified here in the registration name. So now if we run this, we should have the right side wheels should be incorrectly rotated because we oh, what? What's going on? What's going on? Oh, that's where it uses that thing. Okay. Huh. I wonder how it actually did compile then. Oh, it just uses the vehicle controller to get to the vehicle. Like it uses the vehicle controller component to get to the vehicle controller. I see. Okay, so we actually need this, and we need that, and we need that, right? And we need that as well. Yeah. Okay. Yeah, this is the danger with using undefined. We just have this vehicle controller, set it to undefined, and Zig goes, all right, that's fine. And then you try to use it, and you get a crash. So don't use undefined, children. It's bad for your health. Now then, now we should see, okay, correctly rotated, incorrectly rotated, or shall we say not rotated. So that's good. That means that we have the new component. Okay. So what do we do now? Well, the first thing is that we'll bring back that rotation, right? So we need to have some visuals. So we have this handy little struct here for encapsulating everything we need to like put a mesh in the world currently. So let's just call this just like visuals and visuals list and visuals and visuals list, right? Something like this. I mean, we don't really have to do this, but if we do this, then it kind of perhaps makes it more obvious that these are not necessarily wheel visuals. They can be anything, and in this case, we're going to use it for the covers as well, right? So so let's do cover visuals. And this is going to be, there's going to be 4 of them. And they're just visuals like this. And this would also be undefined because we can't init that array here. Okay. So at this point we're going to need, like a cover mesh. And we need a cover material. Maybe we can call them path. And when we exported the mesh from Blender, the Basis Asset Server picked that up and converted it with that path, so we can just use that. Means vehicle mother wheel cover dot bin mesh. So bin mesh is the runtime format it will end up with. And we can go to mother chassis. Yeah, what materials do we use for the chassis? So it's just mother chassis bin material. Mother chassis bin material. So it's essentially this guy. It's the basis node material, and we can just do wheel cover basis node material. Let's open that up. Means project, the wheel cover, and we can just, I don't know, make that a green-ish color, right? Let's copy that guy, something like that, make it slightly darker, and call it a day, essentially. So oh, I need to export it still. Let's export it. Don't forget to export, and we'll get the bin material, which we can copy from here. And now we have the material as well. So wheel cover bin mesh, wheel cover bin material. It should be called mother wheel cover, maybe. No, it's called wheel. Yeah. Anyway, that will work. Okay, so create visuals. How do we create the visuals for this guy? All right, so let's have a look at this one more time. Right, so if you have, let's take this, do a print screen of that and copy it into Paint. See if I can draw on this with an actual drawing pen this time. Seems to work. So if we can zoom in, can I zoom in? Oh man, Paint is so bad. Paint is so bad. Anyway, if we have the origin of this cover situated here, sort of behind or in between the wheels, where this cursor is, and we need to somehow update these positions according to how this wheel moves. This one, so situated here, and we have another one which is situated there. So basically what we can do is we can calculate the center point between these two, which will be here in the center, like this. And then as this moves up, this guy can essentially just, well, that's not a very good line. It can essentially look at that if it moves up, and that makes essentially like this side rise and this side go down. That should essentially be everything we need, right? But we also need to take, yeah, we need to have this position here, that one. We need to be looking at that position, and we need to use the up vector of the vehicle itself. If we do that, then we should be able to position these guys correctly. I think that is all I need. Let's see if we can make that happen. I'm just gonna put away the drawing tablet for a bit and move that out of the way. Because this guy's pivot point, which is this, it's this yellow little dot here. It sits in the middle of the cover, essentially along all axes. Yeah, so that should be fine. Okay. All right. So how do we actually get these visuals into the game? Let's just open another one of these guys and see how we do it for the wheels. So we have this visuals struct, and we also have now this array of 4 visual objects for the covers. So in create wheel visuals, which is here, which is not a public function because it's created from this create wheels. We get a list of the resources, so the materials and the meshes. We use the resource manager for that. We acquire the resource with the given path. And then we get the shared mesh and material, which basically just means that the shared mesh or the shared material is the one that's common for all of the for that acquired resource. You can, of course, just get a resource and then make like a copy of a mesh and start poking at its data. But the shared mesh and shared material is what we want in this case. And then, yeah, we just create an array. An array of, because the system expects a materials array here. So this is just Zig's syntax of going like, hey, get me an array of material pointers, and this is the thing, just one element. Then we use the render scene, which we already have here, and we create a render scene to create a dynamic mesh instance with the mesh and the material. We create a scene node, and we attach that scene node to the render scene node. So create child node, and then we attach the mesh instance. Right. So this is going to be sitting underneath the main scene node of the vehicle, which is perhaps a little surprising, but maybe that is because the transform is actually reported in local mode. Yeah, local transform. Okay, that's probably all right. Then that means that we can do this same with the covers. We can also place them under the render scene node. So let's look at this. So self is self. It's this guy. We get the context from self. Context is sort of like the base class for a component in basis. Of course, there are no actual base classes in Zig, but context is kind of, you can imagine it as the base class of the component. From the context, we get the transform, and from the transform, you can get the render scene node. So render scene node is just essentially a transform where you can nest other transforms underneath it. And that's what we do here. We create the child node of that one, which we can then place somewhere under the main scene node, or the main render scene node for the vehicle. All right. That is fine. Then we append to the wheel visuals array, and we have the game object mesh instance mapping. That just means that if something refers to this particular mesh and it needs to know which game object it belongs to, then you can do this, and it figures out, okay, this belongs to that game object. You should typically do that as well. Okay, so we can do something similar to this. Of course, now we need to figure out the order of the wheels. And I'm just going to make a very quick note to myself, I think, here. I'll just draw it off screen here on my Remarkable. 1 second. So basically what we need to do is, let's use Remedy here, it's so damn fast. Right, like if you have the vehicle like this, this is vehicle number 0. So, I'm just drawing a very crude mother vehicle for myself here. this is 0. Let's verify that that is 0. Yes. Left front wheel is 0. That would be 0. Then we have right front wheel. So it's like, it's that guy. That's 1. Then we have left rear wheel. So it would be this one. So that's number 2, and then number 3 is the one on this side. Like that's how it works. And then you can have middle wheel. So that's rear. Left front middle wheel, right front middle wheel, right? So then it's that one, and then it's that one. So that would be 4 and 5, and then left rear middle wheel and right rear middle wheel is 6 and 7. All right, so the cover that goes here is using wheels 0 and 4, then 6 and 1, and then we have 1 and 5, and 7 and 3. And the reason for this weird order of wheels is that basically the rule is that even wheels are always on the left side, odd wheels are always on the right side, and for a 4-wheel vehicle it always goes 0, 1, 2 and 3. And the same actually goes for vehicles with more than 4 wheels. So we have 0, 1, 2, and 3. And then the middle wheels come after that. I don't remember exactly why it was done that way, but that's the reason. Yeah. I hope this is correct. It's been a while since I've had to deal with things like this. Yeah. Boop. Anyway, let's shut that down. Get a little bit of coffee. Good coffee. Okay. Right. Let's go and start figuring this out. So, Visual Studio Code is trying to be fancy again. Don't be fancy. Okay, so we have 4 of these covers, and actually I think these might need to be members. So let's make them members. So we have something called, what should we call them? Cover wheel mappings, right? Which is an array of unsigned integers. And can I do this? I hope I can. Let's see. Can I do that? Is that fine? Is that all right? It doesn't seem to be all right. How did this work? I haven't been writing that much Zig for a while. Is that all right? It doesn't seem to be all right either. I don't remember. How do I write an array? Let's see if this builds actually. It's just not. Okay, let's go online and figure that out. So Ziglang. We're gonna do learn, and we're gonna do. We're not at the very most recent version of Zig, but we're pretty recent still. Arrays. Right. Okay. So we're right. So I was almost correct earlier, but I think I probably need to have like a const here, right? Something like that. No. Oh, yeah, right. Okay. Something like that, I guess, and then const, and then that needs to be And then I guess that needs to be that. Now it should work. Yeah, because excuse me, this basically sets up a const array. This is not like a member variable now, but it doesn't need to be. That's completely fine. Okay, so I do wonder though, can we do some kind of tuple, because we need like a pair. Can do like a tuple? Tuples, yes. Tuples. Okay. Yeah, that's how you make a tuple. Can I make like an array of tuples? Pair. There's not something called a pair here. Yeah, because I mean this can be an array of unsigned integers, and that'll be fine. Yeah, let's just make it an array of unsigned integers. I don't care about any tuples or anything right now. Okay, anyway. So, the first pair was 0 and 4. The second pair is 1 and 5. Then we have 6 and 2. And then we have 7 and 3. Right, those are our cover wheel mappings, and constants should begin with a big letter, capital letter. All right, and so every 2 elements specify the wheel indices of a cover. Right, and cover order is left front, right front, left rear, right rear. Okay, that should be all right. So now we know that if we use these indices and we go into wheel visuals, we can access the wheels and we can get their scene node, and from that we can get the position to look in, essentially. Okay, and right. So we can do var cover material resource, which is basis resources, resource manager, acquire resource. And this would be wheel cover, or was it just cover material path? But this is a material resource pointer is the type, and this is cover material path, right? Like so. And yeah, it gets cranky because I don't use it, so we can just yeah, it's an optional, and we're gonna actually assert here that we get it, and just assert that cover material resource is not null. Thank you very much. Then we do var cover mesh resource is basis resources resource manager acquire resource, and this would be a mesh resource pointer, and cover mesh path, and same thing, we'll assert that as well. So I take some liberties with, actually we don't need the 0 because we're not going to be using that after that. I take some liberties with my Zig error handling. Most people would not do it like this. The thing is, though, that if we run this code at runtime, we can't find this this guy. We need to basically just do hard error. Something is wrong, rather than try to sort of handle it gracefully somehow. Handling errors in games gracefully. Well, there are certain errors that you need to handle gracefully. Things like network failures or that kind of thing. But just like we tried to load something and it's not there, that's a hard error, and you need to make the user aware of that thing. So this is not really like the way you're supposed to use optionals, but in this case it is the correct thing to do. All right. What then? So now we can essentially do a for loop, which always iterates from 0 to 3, because we always have 4 covers. And we start essentially connecting that stuff together. Here's actually one thing that we could do here. Instead of doing catch unreachable, which is kind of similarly not cool, we'll do append assume capacity. It's kind of like the nicer way of doing that. And then we don't need to catch unreachable there. I'm going to do the same thing for this. So we use the same I we used earlier, and while I is less than 4, we basically take this kind of stuff. Actually, we don't need, we can just do let's put that like in its own scope, right? We can do that. We can do that, right, Sig? I think we can do that, and then we do this, and we can even do that. We need to release that somehow. No, we don't need to do that. Okay, so I can even simplify that just a little bit. So we do cover material, and we do cover mesh. I don't think we need that really. Cover material resource, so that's that. And then we have cover mesh resource, that's that. And then we do this. We do cover mesh instance, and we do cover scene node, like so. We do cover mesh there, and we just plonk this in. Actually, now we can probably do. We can take the. That's annoying. Let's just do this instead, right? That we can do. Cover materials. So it would actually be. It would actually sort of be that one, right? I think that's what we want to do. So we have cover mesh, and we have cover materials, which is an array. We just do that. And we attach the cover mesh instance to the scene node, something like that. And we don't actually set the transform here at all. No, we only set them here. So we can do the same thing for the wheels. I mean, we can do the same thing for the covers. If the wheels are not in place, it doesn't make sense to try to set them either. And of course, this we need to do inside of the loop, like so. And we need to do that as well inside of the loop. But we have cover mesh instance there as well. Cover scene node Do we need the material there? I don't think we need the material there. How's that set up? I'm not even gonna put a material there. Just put a null there. Mesh, we can, I guess, put the cover mesh there. That's fine. And then, what was the name of the list? It was cover visuals, and it's just like a raw array, which means that yeah, maybe it should just be a visuals list as well. So we have wheel visuals and we have cover visuals, and they're both visuals lists. Why not? And that means that we can just use this same append assume capacity for that as well. And that as well, right? Cover mesh. Material, I don't think we need. Do we actually even, do we use this for anything? Well, we keep it around because it's reference counted, right? But the mesh instance will also hold on to it. So yeah, I think this is probably fine. Let's go with this for now. Yeah, let's go with this for now. Let's see if this actually builds. No. Get shared mesh. What? Oh, yeah, that won't work, but that should work. Right, okay, yeah, we need to initialize that to something. So cover visuals is try visuals list init, and it's empty at the beginning. Right, that succeeded. Good. Okay, so let's just do a very quick pass here where so we're already releasing the resources that we're holding on to. We don't need to care about those. We basically just do a very quick iteration over the wheel visuals, and this would be like not a wheel visual, sorry, cover visuals. And I now realize that I have actually pushed to the wrong list. So we do that, and then we do cover, and we have cover scene node attach all. We do that. We do that. We do that. We do that, but we don't do that because we haven't really assigned the material there. Yeah. So now we should be getting rid of it too. And that's always nice to sort of do the whole lifetime of something really before you kind of start messing around with it. And now we can start messing around with it. And what we can do here is we do intick. So right, we do for self dot cover visuals dot slice, and we will get again the cover. We'll get the index. And this is, by the way, this is how SIG wants you to, I think this is called capturing, if I remember correctly. So you're capturing the cover, which is like a pointer to the cover of the current element. and then the index, if you want it, you can put it next to a comma. Okay, so wheel info, and now this cover wheel mappings thingy comes into play. So we'll do wheel. We can do something like const front wheel index, and that would be cover wheel mappings, and I, right? No, actually it will be I times 2, right? And this will be I times 2 plus 1 is the this would be the rear wheel index. And yeah, I'm gonna use them, just chill zig. Okay, and so that would be front wheel info. That would be self dot vehicle controller dot get wheel state info front wheel index. I wonder why the indentation is sort of not really working right now. It's weird. That is weird. But it can't be helped. And out of these infos, we can get the actual positions and orientations, right? So we can do front wheel pos is front wheel info dot local transform dot position, and we can do rear wheel pos is rear wheel info, and then we can do something like cover pos is front wheel pos add rear wheel pos and divided by or multiply float 0.5, right? And this should give us a vector 3. It does, and we can do now finally to shut that thing up about the unused cover. We can do cover dot hello. It doesn't seem to really know what it wants to do, but we can do set position cover pos. Let's see if this builds. It does build. Okay, I wonder if this actually now works. So we're still not rotating them, but with a little bit of luck, we have them roughly where they need to be, and we don't. Okay, that's because we only built them in the debug mode, of course, and I typically build debug because it's just faster to build. It's almost instantaneous, almost. But with SIG, well, release can take a little bit more time. Right, so now then. And hey, we have some things, and now they should move sort of up and down with these wheels. If I'm not completely bad at math, and looks like I am not. This looks kind of fun. And of course we need to rotate these still. And I now realize that we haven't properly UV unwrapped these guys, so they're gonna look really bad because of that. But I mean, this already looks kind of interesting. I'm not sure it looks all that good, but it looks kind of interesting to have them move like this. but let's still try to rotate them properly. And yay! Yeah, it kind of highlights the suspension a little bit, which is always fun. Suspension is always fun. And of course we have this problem where they just poke out through the covers. So we're gonna have to do something about that as well. It looks kind of silly. But one thing at a time, one thing at a time. Oh. Oh well. Yeah, it might be that we have... Actually, we can try... I was a bit too fast with my exiting there. Let's just see. We should see here what is it that we have. We have actually quite a lot of things. Unreleased pipeline for material. Oh, PSO for material. Right, so okay, we're not apparently not releasing everything. How we should be doing it. Okay, I see what's going on here. Yeah, we need to actually, we need to do this thing here. We need to do that thing there, and we need to do this whole thing here where we have const cover material, and it would be this guy like that, and then we have like that, right? And then we have cover material is there. Yeah, because this returns a reference, and we could just release it here after we've created the mesh instance, but maybe it's cleaner and nicer this way. Maybe it's cleaner and nicer this way. Right, so now we shouldn't run into that problem anymore. Let's just make sure now it shuts off nicely. Okay. Right. So one thing that we can do immediately is we can flip the transform. So let's doodly do. So we need to do essentially this, but for the right side wheels. And I wonder if we do like var orientation. I'm going to do like local transform as a basis math matrix 4.3 is transform actually no basis math 4.3 from orientation and position. Yeah. I guess we can just do this. Local X, that would just be, let's put in some shorthands here. These lines are going to be so big and long otherwise. 4.3 is basis math 4.3, and then we do const vec3 is basis math vec3. Right, so we can just do that, and we can do that. And local x would then just be vec3 dot unit x. Local y would be vec3 dot unit y. And local c would be vec3 dot unit c, unsurprisingly. And then position would be cover pos. Right, and if we are right side wheel cover, right, then we just do, All right, that's like a quaternion thingy. We can do that at the end when we actually, yeah, like, can we do blah 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 blah. Ori is, or yeah, need to be a variable, and we can do local transform. Or we can maybe do actually even, I should put in a shorthand for this as well, but from rotation matrix. Oh, right, it needs to be actually called on this kind of thing, so just make it basis. Come on. Identity. And then we can do ori dot from rotation matrix, and we can do local transform. Right, and now we have ori here. Maybe we can do this nicely and set them at the bottom. So then we do orientation would be ori, and maybe this should be to get with the standards. We just do this and that and that. And now then, that should cover the flipping of those guys. And that's it. We can just run it, and I should really put in that play level addition so that it would boot right into the level, but yes, that looks good. That looks good. Okay. Is that? I'm just gonna make sure that my math is correct, like that these guys sort of move correctly, and they kind of seem to do. They seem to do that. Okay, excellent. All right, so this local transform guy now. Then local transform. Look at. We can do, I guess, look at safe. So I position is. If we need to set that, then we can just. We don't have to do any of that. Just do math43 identity. Identity. That would be cover position. Look at position would be front wheel position. And up there would be actually just, because this is in local space, it would just be up, which is vec3 dot unit y. Right. Right. That should be everything we need, right? And I think now comes the tricky part. If we get this working, the tricky part next would be to just rotate it just a little bit according to that, because I don't think they should necessarily rotate completely according to those wheels, but just like a little bit. Let's see, does that work? Oh, look at that. Yeah, now they're sort of fixed with those wheels, and I think this looks already quite fun, but I'm not sure they should rotate quite that much. It would look fun if it would sort of only partly be driven by those wheels. Still let the wheels sort of have a little bit of movement inside of the covers. That could be kind of fun. But that looks kind of fun already. Let's see if we can figure that out. How do we do that? How do we do it? So one way we can do that is by having this transform and this orientation. Let's see, local transform, blah blah blah. Cover. We only really use this transform to build this orientation, but that's fine. That is fine. How did it work? Was it basis, math, quaternion, slurp? So slurp allows us to slurp between two quaternions. In other words, spherical interpolation, which is exactly what we want. So, so yes, and the thing we want to slurp between is this guy, and quite simply no rotation at all, right? Identity, and this would be, let's say, 0.5. Still no F. And we can just overwrite that guy, right? Let's just put in a shorthand for that as well. Let's call it like quat or something. Quat basis math quaternion. And now we can do quat and quat. I'm gonna stop saying quat now. What? There we go. Right. Yeah, that should work. That should make it sort of just rotate just a little bit. Just a little bit. Let's see if that builds. And it does. Cool. So now then, this is kind of math that typically goes wrong somewhere for me. And let's see if it does this time. Hey, doesn't that look nice? Doesn't that look nice? So now it's sort of, the wheels movement only affects the covers sort of 50%. It looks like there's just some amount of suspension inside those guys. Okay, that's cool. I do think, however, that it looks kind of silly that they sort of poke through the side of it, so let's do something about that. And let's isolate this thing so that we can get a good look at it. And what should we do about this? What should we do about this? I'm gonna take that away for now. And maybe we can simply cut a hole in this. That should be fine. So we'll do. We will just simply do the same thing again with this as we did previously. We'll bring that over there, and we'll bring this guy over there. We'll join those two. We'll join those two. It's maybe not the easiest way to do this, but it works. Oh, no. Right, I think we somehow missed the fact that... Oh, no. That these are slightly slanted, so we need to fix them like so and like so. That's fine. And yeah, maybe now we can try the solidifying. So I need to bring it in a little bit. Maybe that can actually... that's interesting. Yeah, let's see how this looks, and if it looks all right, then I'm gonna apply this filter, because then we can do like a proper. Well, we can clean it up a little bit, and then we can do a proper UV unwrapping for it. Or proper. I don't. I mean, I would still probably use just smart projected, but it should look a little better still. All right, let's see. Does this look good? At least good enough. I think it looks kind of fun. That looks kind of fun. Let's go with this for now. It's quite good enough for this prototype phase. Nothing's super obviously poking through anywhere, so... Oh no, oh no, oh no. Yeah. Yeah, I'm not gonna do any collisions for these covers. I bet that's just asking for trouble trying to do that, so let's not even try. Yeah, but this is fun. This is fun. I think this looks better than it did before. So let's do a quick cleanup pass on this guy. So we can apply this guy. Thank you very much. Which means that we get to mess around with this data completely, and we can see that holy shit, what is going on here? So many things are wrong. Collapse at the, what was it? Collapse at the center, maybe? I don't even know what to do. I don't even know what to do. We have the same thing here, probably. Collapse at center. Yeah, this is just completely messed up. Actually, yeah, I think what I want to do here is collapse at last. And come on. I want you, and I want you, and I want at last. That one, and last. That one, last. And that one, I guess last. No, not really. That one and that one last. And then we can dissolve that one, and dissolve that one, dissolve that one. No, let's not dissolve that one, but let's dissolve that one, and that one, and that one, and most of this stuff as well. That looks good. We can dissolve that one, we can dissolve that one. Right. So that looks better. Now we don't have any obviously bad geometry. And now we can just do a smart UV project. Okay. That's it. And I think we're done. Let's just do figure this out, so to speak. I'm gonna bring it into position somewhat. Into position somewhat, and I think that's where we can leave it. But I'll quickly move it there and do an export, wheel cover, boom, and then move it back and save. And I don't think we need that separate. I don't think we need that separate material actually. So let's just use the normal one, which is chassis.bin material, boom, and that means that we can just remove those two. We don't need them. Except now I actually ran it, but I probably didn't build it. So let's not do that. Yeah. Shut this down and release. And I prefer to run it from the Remedy debugger because it is just so damn fast. It's like bloop, and it's running immediately. Okay, so that's good. We have somewhat okay-ish. We have somewhat okay-ish UV mapping. We have somewhat okay-ish movement. And we have somewhat okay-ish handling, since we tweaked the steering a little bit. Yeah. I mean, this is fun. The wheels don't look like they're just sort of floating there anymore. They kind of look like they are somehow attached to the body, even though you can't really see it. We'll see if in the end you actually can see it or not. Yeah, like you're still gonna have these kinds of weird cases here where a wheel just sort of suddenly falls off a cliff, and it's gonna look weird. But that's a problem with the physics, or like a limitation of the physics simulation. We might have to do something about that. We'll see how it goes. Yeah, but I think this is a pretty good place to take a break. Continue next time. Next time I think we'll start looking at the cranes of the mother vehicle. So there's a lot of mother vehicle stuff that we kind of need to front load, but it is such an important vehicle. It's kind of the whole core of the gameplay that I think it makes sense to show it all the love that it is getting. It's just fun watching these wheel covers move when you're driving over uneven terrain. Maybe it's just me, but I think it's really fun. Yeah, that's it for me for this time. If you have any questions or suggestions, just let me know in the comments, and I hope to see you next time. Goodbye.